Okay. Today we're going to be going over question number 3 of the integration by parts worksheet, which the problem is the integral of 0 and 1/3 arc sine 3t dt. Now the first thing we got to do is that the bigger number is supposed to be on top, which means that we just need to switch out the 1/3 and the 0. And because of that, this equation becomes negative. And it turns into this integral of 1/3 to 0 negative arc sine of 3t dt. Well, we're just getting started here. The bigger number is supposed to be on top. That's right, we got that, yep. To evaluate the definite integral, we first need to evaluate the indefinite integral. So what we're going to do is we're going to, let me move this a little bit here, we are going to give our little integral over here a haircut. And it might be more of a buzz cut because now he has no more hair. Next step is to use the property of the integral, which basically what that means is that you see that negative right there, negative, we don't really need that negative in this equation, and we can just move that right onto the outside. And there we go, negative integral arc sine of 3t dt. And now, the next step we must use is substitution. What we'll be using for u and du. So our u is going to be 3t. And the derivative of the du, the derivative of u, will be, of course, 3. If we replace the numbers and fill it in, do a little bit of diddly-diddly-do, and suddenly we got negative integral arc sine of u divided by 3 to the du. The next step is to use the property of the integral, which in the formula would be the integral of a times fx dx equals a integral of fx dx. Basically, we just translate it from the formula we had to the formula we need now. I think it'd be easier if I show you a picture. Here it is. So what we did was we took out the 3, and we said we don't want that 3 anymore, and we're moving it on the outside with the negative. So now it's negative 1/3 times the integral of arc sine u du. Look at that, it's getting more simple as it is. Next, we need to use this partial integration. And also known as to stretch out the formula in a way. We're going to just stretch out a little bit. And that's going to be stretched out to, basically we're just adding a times 1 here. This times 1 will be important for later. And now it's time for us to use even more substitution. We're going to have the second u be the arc sine of u. We're going to have the second derivative of u equal 1 over the square root of 1 minus u squared. Because if we look on the formula sheet, that's what the arc sine of u, the derivative of an arc sine of u equals. So we also, the derivative of v, we're going to add a new value. It's a new variable, the derivative of v. We're going to have v in there. And that one's going to equal the 1 we put in. That one right there. And the v of that is basically u. So if we plug both of those in, it will equal an atrocity that looks like this. Look at that, that's hideous. But don't worry, we can clean it up a bit. You see that u over there? This u right here, this u wants to take over the world. And how does it do that? Oh, it knocks over the king. It knocks over the current king in charge, which is that 1. And now u is on top of the world. So u is controlling the land that is this math problem, and everything's going into chaos. What can we do to solve this situation, this tyrant, to overthrow him? More substitution. We have a second v, and that equals the square root of 1 minus u squared. And that will turn this equation into a little more like this. See, look at that. His throne is destroyed. There is no more u, except for these ones. But those ones are important later. Next, we need to remove the integral. So this baby right here needs to go away. We need to get rid of him. And that will end up turning into this one right here. Because we don't really need the integral anymore. And the equation becomes negative 1/3 times the arc sine of u times u minus negative 1v. Because because the derivative and the integral, they kind of get rid of each other. Now, remember when we substituted v? Well, v decided, I'm going to be a villain today and bring everything that was contained in itself. He just relapsed himself out there. And now, look at this. Our peaceful, ever so peaceful problem without any derivatives or square roots or fractions, any ugliness, is now getting more stretched out and more stressed. And if any Batman movie has taught me, there is always a second villain. And this is where the U comes in. Or at least what was in the U. And now we have all these different numbers causing a mere chaos amok the city of that is my problem. So there is a way that we can fix this. There is a hero that can come to our need. But in order to get this hero, we need to use its signal. And by signal, I mean simplification. And we're going to simplify it. Just move some numbers around, get it in an order, more organized order, make it vulnerable and able for the hero to come in and save the day. And who is this hero that I am referring to? Why, it's the limits. The limits, they're back! And they're better than ever. They come back, and the final battle ensues. We plug everything in, and this little symbol right here, the hero comes in, and epic battle comes in. That means every t that is here is being replaced with 1/3 and 0, and it's being subtracted from each other, which it turns into this. I might need to zoom out a little bit, but if I were to explain the final battle to you in words and numbers, it would be -1/3 times the arcsine of 3 to the 1 times 1/3 times 1/3 minus 1/3 times the square root of 1 minus 9 times 1/3 squared minus -1/3 times the arcsine of 3 times 0 minus 1/3 times the square root of 1 minus 9 times 0 squared. Whew! And after the dust settles and the fighting is all done, we use some simple simplification to just clean up the streets a bit, dust away all the debris, and we get the final answer. That is -pi/6 minus 1/3. That's it. That's it, baby. Yeah! I had way too much fun with this.